Which vehicle is more aerodynamic? The BMW M1 or a Toyota Sienna minivan? The answer may surprise you. Aerodynamics plays an essential part in the design process of both passenger automobiles traveling on our roads and the race cars speeding down the racetrack. Cruising down the street at low speeds, you probably do not think much about how the surrounding air interacts with your car. However, at higher speeds, you will quickly understand how air resistance and your car's design are closely connected to your car's performance. Aerodynamics is the study of the properties of moving air and the interaction between the air and solid bodies moving through it. The aerodynamics of a car has a tremendous effect on the way an automobile accelerates, on wind noise, and on mileage. It also affects how potential buyers perceive the car. We can think of aerodynamics as the way a vehicle cuts through a wall of air. The engine of a more aerodynamic vehicle doesn't have to work as hard to push the car through the wall of air as the engine of a vehicle with poor aerodynamics. Aerodynamics can be separated into two separate forces, drag and lift. Designers limit air resistance, also known as drag, in a variety of ways. They might limit the air resistance with enclosed underbodies, flush headlights, rounded shapes on the exterior that channel the airflow around the car, or by using a spoiler to decrease lift and keep the air from lifting the car's wheels. Automotive engineers and designers quantify aerodynamics through a number known as the drag coefficient. The lower the drag coefficient, the better a car's aerodynamic performance. The drag coefficient is derived by measuring the effect of air density, airspeed, drag, and the surface area exposed to these forces, the frontal area. The higher the drag coefficient, the less aerodynamic the object. So a flat brick held perpendicular to the flow of air has a drag coefficient of around 1.1. While a raindrop, which is similar in shape to an airfoil, would have a drag coefficient of around 0.05 if it were moving parallel to the flow of air. Wind tunnels are used to test the aerodynamics of a car. A car or model sits inside the tunnel as fans create wind at different speeds to simulate real-world conditions, while computers calculate the drag coefficient for different speeds. Today, most cars achieve a CD of about 0.30. The iconic Jeep Wrangler, for example, has an average CD value of around 0.45, making it one of the least aerodynamic cars. Mercedes-Benz, on the other hand, boasts that their new A-Class sedan features the lowest drag of any production vehicle in the world, with a drag coefficient of 0.22. So which car design shape is the most aerodynamic? If you were to compare a BMW M1 with a Toyota Sienna minivan, you would find that the minivan has a more aerodynamic design. The M1 has a CD value of 0.4, while the Sienna has a CD value of around 0.3. Why? Angular geometric cars like the M1 were popularized by the legendary car designer Giorgetto Giugiaro. He was responsible for designing iconic vehicles like the M1, DeLorean, and the Lotus Esprit. However, sharp angular edges contribute to more turbulent wind patterns. The most aerodynamic car possible would have a low-slung raindrop shape that is pointed at both ends. Most cars on the road today feature some iteration of the raindrop design. The upcoming solar-powered Lightyear 1 EV is expected to have a drag coefficient below 0.20, making it the world's most aerodynamic car. It also has the same raindrop design. Today, the average modern automobile achieves a drag coefficient of between 0.25 and 0.35 by using this design. Automakers do often break from the trend of using the raindrop shape. It will be interesting to see how car designers innovate and push automotive shapes forward to create more unique designs. What is your favorite aerodynamic vehicle?